All right, so we've been talking about shapes and characterizing them for our past couple lessons. And so we're going to switch gears just a tiny little bit, and we're going to talk about probability because we're going to use some probability and combine it with shapes in some of our future lessons. So let's talk about what exactly probability is. This is just going to be an intro to probability. We're not going to go too deep into it until way later on in the course. But probability is essentially how likely an event is to occur. And so probability can be represented as a number from 0 to 1. And so if we say the probability of something is 0, then that means that that event will not occur. It's completely impossible. If we are certain without a doubt 100% that that event will happen, then we can say that probability is 1, or as I just mentioned, 100%. So not only can probability go from 0 to 1, as a percent it can go from 0% to 100% likely. And so essentially those numbers tell us how likely an event is to occur. So then you might be like, okay, well, what's an event? Well, in probability, we have what's called a sample space. And a sample space is the set of all possible outcomes. So we're going to break this down into something that maybe we can all relate to. I'm sure all of you have played with a deck of cards. We know a deck of cards has 52 cards in it. So my sample space is going to be that all 52 cards in the deck, excluding the jokers. Any subset from that sample space is an event. So if my sample space is all the playing cards in a 52 card deck, then an event could be drawing a queen of hearts or drawing a club, or I could say drawing a two of hearts. Or it could be drawing a face card. Any potential card that's an option is what we could call an event. Now, I could also have an event that's not likely at all. Like I could say, what's the probability of drawing a 14? Well, there isn't a 14 in a deck of cards, so that would be a 0% likelihood. So that is essentially the difference between an event and a sample space. So then with probability, we also have what's called experimental probability and theoretical probability. And so experimental probability is probability that's based on data that is collected via experiments. So if I flip a coin 10 times, that is me doing experimental probability. If I flip a coin 10 times and I record, did I get heads or tails? If I record the number of times I get those, then that's experimental. Theoretical probability is probability that's mathematically calculated. So for example, if I go back to talking about flipping a coin and I want to know like what's the probability of landing on heads or tails, if I do it 10 times, mathematically, we would probably say you have a 50-50 chance of getting heads and 50% chance of getting tails, right? But experimentally, if I do that, I could flip that coin 10 times and I land on heads 7 times and tails 3 times. So that's the difference between theoretical and experimental probability. Theoretical is the mathematical probability, and experimental is the probability when you actually do the experiment and you collect the data. Okay? So take a look at this example. It says if you were to reach in a bag with 16 shapes, 4 of them have right angles, and you randomly pull out a shape, what are the chances that you would pick a right angle? Well, what we're calculating right now is what we call theoretical probability, okay? If I have 16 total shapes, and there's 4 of them that have right angles, then 4 out of 16, which simplifies to 1/4, means I have a 1/4 chance of picking a shape with a right angle, or a 25% probability. Now, if I do this experiment, if I pull out, if I put all the shapes in and I let's say I conduct this experiment 16 times, okay, because there's 16 shapes in there, it does not mean that I'm guaranteed to draw a shape with right angles 4 times. I could draw no shapes, or the shapes I draw, none of them could have right angles out of the 16 tries that I do. Or I could reach in and maybe I draw 7 times a shape that has right angles. So the experimental probability and theoretical probability can be different, since one is based on experiment and the other is based on mathematical calculations.